What's up, folks? It's Dave with Nemesis Giant. Look at an article dated March 1st, 2017 in the physics.org. It's another soft disclosure article, I'm imagining. It's hunting for giant planet analogs in our own backyard. Notice the artist's rendition here looks a lot like the planet we seem to have floating out there right now. They could at least make things look a little different for us, right? Anyway, they go on to say, there may be a large number of undetected bright substellar objects similar to giant exoplanets in our own solar neighborhood. Really? According to new work from the team led by Carnegie's Jonathan Gagné, and including researchers from the Institute for Research on Exoplanets at Université de Montréal. It is published by the Astrophysical Journal Supplement Series. Similarly aged stars moving through space together in a group, described by astronomers as an association, are of great interest to researchers because they are considered a prime target to hunt for brown dwarfs and free-floating planet-like objects. Recent studies of an association of stars called TW Haya have revealed some of the first known isolated giant planet-sized objects in the neighborhood of our own sun, about 100 light years away. This group contains a few dozen 10-million-year-old stars all moving together through space. How did we miss all this up to this point? In order to determine whether or not there are more standalone planetary mass-sized objects like these in the TW Haya association, Gagné and his team undertook the calculation of an astronomical measurement called the initial mass function. This function can be used to determine the distribution of mass in the group and to predict the number of undiscovered objects that might exist inside of it. The initial mass function of TW Haya had never been published before, Gagné said. In the process of this analysis, the team was able to determine that there are probably many more objects between 5 and 7 times the mass of Jupiter in the association that haven't been discovered yet. The TW Haya association extends out to a distance of 250 light years, but our instruments aren't sensitive enough yet to detect giant planets like members at this distance. Hence, many of them might remain to be discovered. Really? Okay, I had another article here from the same source, dated April 20th, 2016, come from physics.org. Lone planetary mass object found in family of stars. It's another artist rendition of another planet that seems to be out there right now. Why can't they make these things different? A young free-floating world sits alone in space in this illustration. The object, called WISEA-J is thought to be an exceptionally low-mass brown dwarf which is a star that lacked enough mass to burn nuclear fuel and glow like a star. Credit NASA JPL Caltech. In 2011, astronomers technical errors, really. In 2011, astronomers announced that our galaxy is likely teemed with free-floating planets In fact, these lonely worlds, which sit quietly in the darkness of space without any companion planets or even a host sun, might outnumber stars in our Milky Way galaxy. The surprising discovery begged the question, where did these objects come from? Are they planets that were ejected from solar systems, or are they actually lightweight stars called brown dwarfs that formed alone in space like stars? A new study using data from NASA's Wide Field Infrared Survey Explorer WISE and the 2-micron All-Sky Survey, or 2MASS, provides new clues to this mystery of galactic proportions. Scientists have identified a free-floating planetary mass object within a young star family called the TW Hydrae Association. The newfound object, termed WISEA or just WISEA 1147 for short, is estimated to be between roughly 5 to 10 times the mass of Jupiter. WISEA 1147 is one of the few free-floating worlds where astronomers can begin to point to its likely origins as a brown dwarf and not a planet. Because the object was found to be a member of the TW Hydrae family of very young stars, astronomers know that it is also very young, only 10 million years old. And because planets require at least 10 million years to form, and probably longer to get themselves kicked out of a solar system, WISEA 1147 is likely a brown dwarf. Brown dwarfs form like stars, but lack the mass to fuse atoms at their cores and shine with starlight. Amazing how nobody ever heard of a brown dwarf star, and now everybody knows everything there is to know about them, where they came from, and everything else. With continued monitoring, it may be possible to trace the history of WISEA 1147 to confirm whether or not it formed in isolation, said Adam Schneider of the University of Toledo in Ohio, lead author of the new study accepted for publication in the Astrophysical Journal. Of the billions of possible free-floating worlds thought to populate our galaxy, some may be very low-mass brown dwarfs, while others may in fact be bona fide planets kicked out of nascent solar systems. At this point, the fraction of each population remains unknown. Tracing the origins of free-floating worlds and determining whether they are planets or brown dwarfs is a difficult task, precisely because they're so isolated. This is a sky map taken by NASA's Wide Field WISE. Shows the location of the TW Hydrae family or association of stars, which lies about 175 light years from Earth and is centered in the Hydrae constellation. We are at the beginning of what will become a hot field, trying to determine the nature of the free-floating population and how many are planets versus brown dwarfs, said co-author Davy Kirkpatrick at NASA's Infrared Processing and Analysis Center, or IPAC, at the California Institute of Technology in Pasadena. Astronomers found WISEA 1147 by sifting through images taken of the entire sky by WISE in 2010 and 2MASS about a decade earlier. They were looking for nearby young brown dwarfs. One way to tell if something lies nearby is to check to see if it's moved significantly relative to other stars over time. The closer an object, the more it will appear to move against a backdrop of more distant stars. By analyzing data from both sky surveys taken about 10 years apart, the close objects jump out. Finding low-mass objects and brown dwarfs is also well suited to WISE and 2MASS, both of which detect infrared light. brown dwarfs aren't bright enough to be seen with visible light telescopes, but their heat signatures light up when viewed by infrared images. The brown dwarf YSA 1147 was brilliantly red in the two-mass images, where the color red had been assigned to longer infrared wavelengths, which means that it's dusty and young. The features on this one screamed out, "I'm a young brown dwarf," said Schneider. After more analysis, the astronomers realized that this object belongs to the TW Hydrae Association, which is about 150 light years from Earth and only about 10 million years old. That makes YSA 1147, with a mass between about 5 to 10 times that of Jupiter, one of the youngest and lowest mass brown dwarfs ever found. Interestingly, a second, very similar low mass member of the TW Hydrae Association was announced just days later by a separate group led by Kendra Kellogg of Western University in Ontario, Canada. Another reason that astronomers want to study these isolated worlds is that they resemble planets but are easier to study. Planets around other stars, called exoplanets, are barely perceptible next to their brilliant stars. By studying objects like YSA 1147, which has no host star, astronomers can learn more about their compositions and weather patterns. We can understand exoplanets better by studying young and glowing low-mass brown dwarfs, said Schneider. Right now, we are in the exoplanet regime. Very interesting. So we're learning more and more about brown dwarfs all the time. Well, there's another one for you, ladies and gentlemen. I'll see you again next time.